You ever look at quantum computing and just think, no way, that's for super geniuses, right? Well, what if I told you that learning to program one wasn't some crazy physics final? What if it's actually a journey, a step-by-step path that anyone can walk? That's what we're going to do today. We're going to demystify this whole thing.
All right, so where do you even begin? I mean, really, how do you go from a totally blank screen to actually programming one of these things, using all that weird quantum power? It sounds like something out of a movie, I know, but there's a path, a really clear one, actually. So let's just dive right in.
Okay, let's think of this like a quest, a big adventure. And every good quest needs a map, right? Well, our map is a real-world curriculum called Mastering Qiskit v2.0. This thing is going to be our guide, taking us from square one all the way to running our own code on a real IBM Quantum computer. For real.
And look, I want to be super clear about something. This is not going to be some boring lecture on deep quantum physics. Nope. Think of this as a practical walkthrough. We're focused on the doing, the actual concrete skills you'd learn, step by step, to get this really powerful new ability under your belt.
So what's the loot at the end of this quest? What do you get? Well, think of them like superpowers. Seriously, you're going to be able to connect to real quantum hardware. You'll be able to reach in and actually manipulate those weird quantum states. You'll build and run your own programs. And maybe the coolest part? You'll learn how to clean up the messy results you get from today's machines. These aren't just ideas. They're real, powerful skills.
All right, so where does a journey like this even start? Every epic quest has to begin with those first few steps. You don't just go out and fight the dragon on day one, right? First, you got to learn how to hold the sword.
And what's so cool about this is how logical it all is. It's not a huge leap. You start with the simple stuff, the absolute basics, getting the software set up on your computer. Easy enough. Then you connect to the cloud services. Okay. Next, you learn to control just one of these quantum bits, a qubit. After that, you learn that famous quantum trick, superposition, making it be a 0 and a 1 at the exact same time. And then, the grand finale for this section, you link two of them together to create what Einstein famously called spooky action at a distance, entanglement.
And just like that, in 5 simple steps, you've gone from a blank screen to creating one of the most famous, most mind-bending things in all of physics. That's incredible progress, right? And that foundation is what everything else is going to be built on.
Okay, so you've got the fundamentals down. What's next? Well, the next part of our quest is about building out your toolkit. This is where you really start to learn the craft of being a quantum programmer.
And the main tool in that kit is something called the Qiskit stack. The best way to think about it is like your personal quantum workshop. It's got two main parts. First, there's the SDK. That's your toolkit for actually designing and building the quantum circuits. Then there's the runtime. That's the part that takes your finished design and actually runs it on the real hardware. And this is where things get really practical, because you learn there are two main ways to build these circuits. The first way is what we call programmatic construction. Think of this like building with individual Lego bricks. You have total control, putting every single piece in place yourself. It's perfect for custom, complex stuff. The other way is to use the circuit library. This is more like using those awesome pre-built Lego sets or modules. It's way faster for prototyping and using standard patterns. And the thing is, you need to know both. They're both essential.
All right, basics are covered. Your toolkit is starting to look pretty good. Now it's time to get fancy. We're going to start combining all those skills into way more powerful and complex techniques. So, if the first few steps were like learning the ABCs of quantum programming, this next part is where you start writing poetry. You're about to learn the advanced spells, the really cool tricks that give you pinpoint control over your quantum programs.
Yeah, this is where we go way beyond simple circuits that just run from start to finish. You're going to master things like conditional logic, which is huge. It means your circuit can run, make a measurement, and then, based on that result, it can change what it does next, all on the fly. Then there are fractional gates. These are like having a dimmer switch instead of just an on-off button for your qubits. The level of control is just incredible. And of course, you learn how to optimize your circuits, how to make them smaller, faster, more efficient, which is so important for the hardware we have today. And finally, you learn how to package them up, serialize them, so you can save your work, share it with others, and make sure your results can be reproduced. This is really when you start to think like a quantum programmer.
So all that training, every skill you've picked up so far, it's all been leading to this. This is the climax of the whole journey. It's time to leave the clean, perfect world of the simulator behind and run your code on an actual, real-life quantum computer.
This is it. This is the moment you face the final boss, and that boss is the real world. Because as you're about to find out, the real world is a lot noisier and a lot messier than the perfect blueprint you've been working with.
Just look at the difference here. When you're in a simulation, everything is perfect. It's a clean, quiet world where the qubits do exactly what the math says they should. The results are pristine. But in reality, real hardware, oh man, qubits are unbelievably sensitive. The tiniest change in temperature, a little vibration, it can all create interference. We call this noise, and what it does is mess up your results with errors.
So, what do you do about that? How do you fight the noise? Well, this is the final and maybe the most critical skill on the entire map. It's called error mitigation. And honestly, this isn't just another technique, it's the master key that unlocks the power of today's quantum computers. See, since we can't build perfectly silent hardware yet, we use these really clever software tricks to find the real signal hiding inside all that static. It is, without a doubt, the most important skill for getting real, useful answers from a quantum computer today.
And that right there, that's the real win. That's the end of the quest. You haven't just learned how to shout instructions at a quantum computer. You've learned how to listen to its noisy reply and figure out what it's actually trying to tell you. You've learned how to pull a meaningful, accurate result out of the chaos. Now you're ready for the real world.
Now look, if this whole journey still sounds like, a lot, I totally get it. But I want you to hear this. This is from the people who designed this learning path. They said the whole thing is modular and incremental, and they prioritize practical coding demonstrations to bridge theory and implementation. What does that mean in plain English? It means the path is broken into small, manageable pieces, and it's all about getting your hands dirty with code, not just staring at equations. It's designed from the ground up to be something you can actually do.
So there you have it. We've just walked through the entire map, from the very first step of setting up your computer, all the way to tackling noise on real quantum hardware. The path is there, it's clear. So the only question left for you is, now that you have the map, where are you going to go? What problems are you going to solve?